Okay, so we have S1 October 2021. Let's have a look at this paper. So here we go. Okay, question 1. So this should be quite a nice easy question. It's a 7 marker, all right? So the Venn diagram shows the events A, B and C and their associated probabilities where P and Q are probabilities. Okay, if we know that P and Q are probabilities, this is all probabilities, what do we know they all add up to? 1, perfect. So because it's told us that, we immediately, without reading the rest of the question, I know that all of these are going to add to 1, okay? So that means that P plus Q plus, and then I'm going to have 0.7, 0.8. So that actually this equals 0.2, because 1 minus 0.8 is 0.2, so we already know that. Now it says find the probability of B. Well, the probability of B is P, Q and 0.3. So we've got P plus Q plus 0.3. Now if you just write that, you're not going to get the mark. Okay? Because in actual fact, what do we know that P plus Q equals? 0.2. So instead of writing P plus Q, we put 0.2 plus 0.3, we're actually going to get 0.5. So determine whether or not A and B are independent. Now they don't give you this on the formula sheet. However, we do need to memorize this. Make sure you write it on there. If P and A are independent, what is the rule? We know that their intersection is the probability of A multiplied by the probability of B. This is for independence, isn't it? Okay, so if independent, upper independence. Anyway, so for independence, so let's have a look at the probability of A intersection B is PQ, which is 0.2. What is the probability of A? Now the probability of A is in fact 0.04, 0.006, P plus Q. Is everyone happy this is 0.3? Yeah, P plus Q is 0.2. So this is 0.3 multiplied by the probability of B, which we know is 0.5. Now, 0.2 does not equal 3 times 5 is 15, isn't it? So this is 0.15. They do not equal the same, therefore, not independent. Perfect. Okay, now obviously you'd write this really lovely on the lines and everything. Okay. Now, it says, given that the probability of C given B equals the probability of C, find the value of P and the value of Q. Okay. So what does the probability of C given B mean? Okay. We know this is a formula. What is the probability of C given B? This is the same as saying the probability of C intersection B over the probability of B. Okay? What is the probability of C intersection B? P. What is the probability of B? 0.5. Okay? Now they're saying that this should equal the probability of C. Now what is the probability of C? 0.06 plus P. Look at C for us. So we're going to have, oh my golly, 0.06 plus P. So what am I now going to do? Multiply both sides, expand, simplify. I'm going to find a solution for P. So I'm going to get P equals, if I multiply both sides by a half, 0.03 plus a half P. Okay? So this means a half P equals 0.03. Is that right? Yeah? So I get P equals 0.06. Anyone else get that? Perfect. Okay, well that's great. What do we know about P and Q? They equal 0.2. So 0.2 minus 0.06. Q equals 0.14. Brilliant. So, nice and easy. Now, it then says, the event D is such that A and D are mutually exclusive. What does that even mean? If A and D are mutually exclusive, they don't even connect. That means A is going to be here, D is going to be over here. Yeah? Okay? They're not even living their best life together. They're not. Completely apart. Okay. Now, it then says the probability of B intersection D is greater than 0. So that means one of two things. Number one, it means that D could intersect here, doesn't it? Okay, so it intersects B, it's mutually exclusive with A. Perfect. Or, you don't have to write them both. Okay, you can do one or the other. Or, D could also be a subset of B, couldn't it? Because their intersection would still be greater than 0. Yeah? So you have two possibilities for D. You don't have to draw both, one or the other will do. So there we have it. Nice and simple. How many marks? 6. Okay, question 2. I love these types of questions. If we have a look here, we've got 1, 4, 8, 9, 12 marks. 12 marks. And every single formula is on the formula sheet that you need for this. You need the formula sheet and common sense. Okay? So, let's have a look at the first one. A large company is analysing how much money it spends on paper in its offices each year. Why am I reading the question? Because I know somewhere in here it's going to ask me to interpret something and it's going to want context. It's going to want the context. So I need to understand what's happening. So the number of employees in the office and the amount spent on paper each year. In each of 12 randomly selected offices were recorded. What does that 12 tell me straight away? N is 12, and I know, basically, I am looking at employees would be my X, it told us in the question, against amount spent on paper. Now, I know they've done P here, so this is money. Now, it says hundreds. Now, watch out for this, hundreds on paper. This means we're going to multiply anything by 100 if we're talking about cost. I'll show you what that means in a minute. So, number 1, show that we've been given some data. Perfect. Show that SXP. Right, straight away, formula sheet. SXP. This is exactly the same as doing SXY. Yeah? But instead of P's at Y's, there's P's. So what is XXY? It says the sum of X, Y. Now, you don't have to write this in the exam. I'm just showing you this formula is the second formula, it's the third one down. Here we go. Now, let's get this information. Now, again, what did I say? This is the formula's in Y's, but we don't want Y's. We want P's. So I'm just going to put P's. Okay, so the sum of SXP. Did we get given that? We did. 2, 3, 4, 7. The sum of X, did we get given that? We did indeed, 93. The sum of P, we were given that, 273, divided by 12. Now, I'm assuming when I put this into my calculator, I'm going to get 231.25. Let's check. Okay, amazing, all done. Right, part B, find the product moment correlation coefficient. What does that mean we want to find? R. Okay? How do we find R? We need S, X, Y, but P, over the square root of SXX, S, YY, in our case, PP. Okay, I have S, XX. I have SXP. What do I need to work out? SPP. Okay? So let's work out SPP. So SPP equals the sum of P squared minus the sum of P all squared over N. So the sum of P squared is 6602.72. 6602.72 minus the sum of P, which is 273, squared over 12. Okay, I'm going to put that into my calculator. So that's 391.97. Amazing. Okay, so now I'm going to have all my information needed. So SXP I worked out earlier, 231.25, all over the square root of SXX is 148.25 multiplied by 391.97. So simple. So I'm going to put this into my calculator. It hasn't asked me to round anything. So if I'm not rounding anything, what should we put it to? 3 significant figures. Absolutely. So my product moment correlation coefficient, what do I get? 0.959 to 3 significant figures. Perfect. Okay, what does that tell me, first of all? Strong positive correlation. Brilliant. So I know there is a direct, literally, it's going to go like this, isn't it? This is a really strong positive correlation. Again, I don't need to draw this graph, okay? But we will need to see what it means in context of the question. So, part C, it says find the equation of the regression line of P on X in the form P equals A plus BX. Again, where am I finding this information? Formula sheet. It's literally there. It tells you in the formula sheet that B equals SXP. I mean, it says as SXY, but we know that P is Y, over SXX. Okay? We've literally worked this out somewhere. SXP. So we're going to have 231.25 all over 148.25. So what do I get for B? 1.56 to 3 significant figures. Awesome. Now, then how do I work out A? A says I want the mean of Y, but in our case, we don't have a Y. What do we have? A P. So the mean of P minus B times the mean of X. Now, how do we find the mean of P? I need the sum of P divided by N, which in our case is 12, minus our B, multiplied by the sum of X divided by 12. Now, we're already given this in, so we're going to have 273. So this is, I'm just going to write it again actually. 273 over 12 minus 1.56. And is this 73? Did I make that up? 93. 93 over 12. Okay, and this is going to give me my A. What is my A? 10.66, which is 10.73 significant figures. So my equation of my regression line is Y equals P equals 10.7 plus 1.56x. Nice and simple. Okay. Next up. It says, give an interpretation of the gradient of the regression line. Okay, we're interpreting this with context to the question. So what does this mean? What does the gradient mean, first of all? Yeah, how steep? So for every one across, we go up 1.56, yeah? So let's think about this in the context of our graph. If I say for every one across, what am I technically saying? Yes, for every one employee. So I'm going to write that down. Instead of saying for every one across, so for every one employee. Okay, so for every one employee. Now, I go up by how much? 1.56. Now, what did I tell you earlier about times? Why was I timesing by 100? Because it's in hundreds. They've scaled it back. We need to scale it forward. So actually, so for every one employee, it costs $156 on paper. Yeah? For every one employee, it costs, and you'd say an extra, wouldn't you? Yeah, because it's like an extra $156. Yeah. Is this yearly? Yeah, it is. A year in paper. Okay, remember, I've got full sentences, I've got a full stop, I've got a capital letter at the beginning, I've got a comma in there. I mean, that's pretty cool, isn't it? Okay. Now, it's really important we get the context. There are so many little of these 1 mark, 2 mark, and honestly, they add up. If you can nail these 1 marks, and it's literally common sense, isn't it? Like, this is common sense. Okay? Perfect. Right. So, next up, it says, the director of the company wants to reduce the amount spent on paper each year. He wants each office to aim for a model of the form. P equals 4/5 A plus a half BX, where A and B are the values found in part C. Okay, so if we think about this, so we now want what? P equals, 10.7. So I'm literally going to write this 4/5 lots of 10.7 plus a half lots of 1.56x. Okay, so what is 4/5 of 10.7? Oh, I've put 8.7. 8.56 plus 0.78. Is that right? Yeah? X. So technically as well, like, we may or may not have to work this out, but what is it now telling us? It now tells us that actually we want to cut down the cost of paper, and that for every employee we really want to be spending about $78. Yeah? So this gives us a bit more context of what we want, right? So, using the data for the 93 employees from the 12 offices. Okay, estimate the percentage saving in the amount spent on paper each year by the company using the director's model. Well, this is easy. So we now have our new equation. We also have an old equation. So we need to figure out what is our, using the data for what? The 93 employees from the 12 offices, right? So our X is over 12. Why? Let's read the question. Because the number of employees in the office X and the amount spent on paper each year in each of 12 randomly selected offices were recorded. So X is 93, but it's over these 12 offices. Okay? So we need to substitute this into both models to figure out the difference. Okay? What happens if we put this into the first model? So in the first model, we get P equals 10.7 plus 1.56. 10.7 plus 1.56 times. So I get 22, times 93 over 12. So in the first model, I get 22.79. Okay? Now, in the new model, I get P equals 8.56 plus 0.78, lots of 93/12. So, 0.78, 8.56, and I get 14.605. Okay, so this is the new model. So if I want to find the percentage, what do we know? We're going back basically. We do the difference divided by the original multiplied by 100. Everyone remember doing that GCSE? Yeah? Okay, so 22.79 minus answer divided by 22.79 times 100. Okay, I get 35.9%. Does it want it to anything? No. So we can leave it as 35.9% to three significant figures. Okay? Nice and easy question, really. Okay, so question 3. Right. So, the median age. If there's 35 people, this is odd. Okay, so to help us, we're going to add 1 to it. Divided by 2. So we're looking for the 18th person. Okay? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So here we go. 53 is the median. Now, the interquartile range. We want the upper quartile minus the lower quartile. Now, if you think there's... How many is left here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I want the median of this. Again, 17 is an odd number. So if I add 1 and divide by 2, I'm going to get 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 45 is my lower quartile. Now I want my upper quartile. So again, if it should be exactly the same, we should just be able to count 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 61. 61 take away 45, is it 16? It is. Perfect, okay? Now, you can also double check this as well. It's always good to do counting. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you can see there's 8 in each side, yeah? We're finding the exact median. Okay, an outlier is defined as a value that is more than 1.5 interquartile ranges above the upper quartile. So, and below, show that there are 3 outliers. Well, first of all, 1.5 times the upper quartile, so 16 multiplied by 1.5. Nope. Yep. What do we get? 24? Everyone happy with 24? Yeah? Now, if I add this to my upper quartile of 61, this means anything above 85 is in fact an outlier. Do I have any above 85? Yeah. 87 and 88. So this is saying any age above 85 is an outlier. And I've got 87 and 88. Now again, for the lower quartile, I've already multiplied it by 1.5, which is 24. So if I do 45 minus 24, I get 21. Anything below 21 is also an outlier. Do I have anything below 21? 13. Okay, so 87, 88, and 13. These are my outliers. And it says show there are 3. That is so easy for 3 marks, isn't it? Yeah? Perfect. Right, it says D. On the grid, on page 9, which we have, draw a box plot for the ages of the male passengers on the cruise. Okay, guys, so for a box plot, we need a few things. We need The median, the upper quartile, the lower quartile, any outliers, and what the last ones are, okay? So, to make it easier, instead of having to keep zooming out and in, you guys are just going to help me. Okay, if I remember correctly, was the median 53? Okay, so 53, we're going to draw a nice line, okay? I know it goes up in ones, all right? Now, next up, lower quartile. 45, was it? Yes. And what was my upper quartile? 61. Am I using a ruler? No, I know I'm not currently, but I mean, should you be? Yes. You should be using a ruler. I'm not using a ruler because I'm on an iPad, okay? Right, so that is how we do the middle bit. Now, do you remember what our outliers were? 13? 88? And 87. So can you see from my outliers, I've drawn these lovely little crosses. Okay. Now, from the stem and leaf, what was the lowest number after 13? Sorry, the next one, 27. So 27 becomes our new minimum. So 25, 26, 27. And can you see, I'm drawing it nice and neat with a ruler, my imaginary ruler. And then what's the highest number before 87? 76? Perfect. There we go. Oops. Nice and simple. 4 marks for that. So easy. Okay. Obviously use a ruler, etc. Blah, blah, blah. Okay. So it says, it shows a blocks plot, blah, blah, blah. Comment on any difference in the distribution of ages of male and female passengers on the cruise. State the values of any statistics used to support your answer. So first of all, we need to make a sentence. We need to comment, and we're going to write a full sentence. What do we see here? It needs to be in context, and we need a statistical fact. There is a higher median age in the females compared to males. So what does that actually mean? It means that the females are genuinely older, because it means 50%. Remember, the median is 50% of the population. Okay? So this means 50% of the population are this age. Okay, so what we would say in terms of context is females... are we talking about a cruise here? Yeah. Yeah. So females on the cruise are generally older than the males. And then you could put as median is higher. And then what is the, and we have to actually write the fact, guys. So the median for the girls is 67, is that right? 67 is larger than, and what was ours? 53. Full stop. Okay? We have to write the statistical name, which we're talking about the median, the numbers, context. Okay? I know it's 1 mark, but it's easy, common sense. Okay. And then says, Anja, along with her 2 daughters and a granddaughter, now join the cruise. Okay, guys, how many people have joined the cruise? Anja, 2 daughters, and a granddaughter. Right. So we got 4 people that's joined this cruise right now. It's like those tongue twisters, isn't it? You know, if your brother was your dad's uncle's age, twice as old, whatever. Right. Anja's granddaughter is younger than both of her daughters. Well, that's good to know. right? So we know we have the granddaughter, who is less than the daughters. I'm going to put 2 Ds for daughters. Who is less than Anja? Oh my God. Anja had her 23rd birthday on the day her eldest was born. I'm going to need time to think for this. Wait there. Yes. So if we do this as DE, yeah? Daughter eldest. So Anja actually equals 23 plus DE. Everyone happy with that? This makes sense to me. It might not make sense to you. Because Anja's going to be 23 years older than her oldest daughter. Because she was born on her 23rd birthday. When their 4 ages are included with the other female passengers on the cruise, the box plot does not change. Okay. So this box plot has no change whatsoever. Now, for this to have no change, what do we know about the granddaughter's age? Okay, what do we know about the granddaughter's age?
So there's 4 people, then it means like her granddaughter and youngest daughter are less than, what was that, 67?
Yeah, but if you think about it, right? If there's 4 of them, okay.
2 on one side, 2 on the other side.
Yeah, we know we're going to have 2 on this side, 2 on this side. Or, in theory, we could have 1 in each quartile. Couldn't we? Because that wouldn't change anything, would it? As long as it didn't affect. So what do we know about the daughter's age? The daughter's age, the granddaughter's age has got to be between 34 and 56. Yeah? There's a fact. Right? So, granddaughter's age between 56 and 34. Okay, how could I write that nicely? 34 is less than, age is less than 56, yeah? Could I put including? We're adding 4. We'll come back to that question in a minute. Right, what do we know about Anja's age? Let's be honest. She's an old woman. Right, what do we definitely know?
She's more than 57.
For sure, she's more than 57. Okay?
She's between 57 and 79.
But if Anja, where would, so...
It would be between like 72
72?
and 90.
It would be between 72 and 93. Everyone happy with that? For sure. It's going to be in the upper quartile. She is definitely between 72 to 93. For sure. But we can narrow it down a bit more. Because this is definitely... The granddaughter's here. The other daughter's here. The eldest daughter's in here. The grandmother must be here. Right? But what do we know about the grandmother? She's how many years older? 23 years older than her daughter, right? What is this, 67? Now, if her daughter was 67, if her daughter was in the middle, right, what's 23 plus that? 90. So actually, do you know what? We've narrowed it down even more. She's between 90 to 93 years old. She's an old lady. I mean, she's fit and healthy. So if I was to repeat that part, right, the granddaughter's definitely within this age, yeah? For nothing to change on this box plot, each age must fit into these categories quite nicely. So I have one here in this quartile. We'll have one here in this quartile. One person dropped in here, one person dropped in here. However, what I'm saying is, imagine she got dropped in here if she was the youngest of this quartile, the eldest daughter. The grandma is still 23 years older. So that's why the grandma's got narrowed down. Okay? So actually, you could say the grandma, which is Anja. So Anja's age is between 90 and 93. Okay? Now, in terms of less than or equal to, they're not going to worry too much about that. All right? Okay, question 4. So, 3 bags, A, B, and C, each contain coloured balls. Bag A contains 4 red balls and 2 yellow balls only. Bag B contains 4 red balls and 1 yellow ball only. Bag C contains 6 red balls only. Okay. So, in a game, Mike takes a ball at random from bag A, records the colour and places it in bag C. He then takes a ball at random from bag B, records the colour and places it in bag C. Finally, Mike takes a ball at random from bag C and records the colour. Complete the tree diagram. Okay. Okay, so let's have a look at this. He takes a ball at random and records it. Now, what's slightly confusing here is they've done 2 over 3. That's because in the red bag, there is, what is 2 out of 3? There's technically 4 out of 6, which is 2 over 3. So you know what? I'm going to put that as 4 over 6 to help me. Okay, so in a game, he takes a ball at random. So in the yellow bag, currently, how many bags, how many yellow? 2 out of 6, which is a third. Brilliant. So in the red bag, in the B bag, there's 4 red balls out of 5 yellow. 5 yellow and red, so that's 1 out of 5 left. Now, he takes a random from bag A, records the colour and places it in bag C. Okay, he takes a random ball from bag B, records the colour and places it in bag C. So none of this changes for the B bag. Right, now we have to think about this. So he records it and puts it into bag C, okay? He takes a ball at random from bag C, records the colour. Now remember, bag C only contained 6 red balls, okay? Only 6 red. But if we're adding from the bag A and B, we technically know there is going to be out of 8 balls. Okay, that is what we know for sure. Now, if we take a yellow from A and a yellow from B, we're going to put these in bag C. There's 2 yellows and there's 6 red. Now, all it's asked us to do is by adding the remaining branches and all probabilities. So we actually need to add all the remaining branches. Okay, so we've got another branch here, another branch here, another branch here. Again, we have red, yellow, red, yellow, red, yellow. Okay, so I'm going to do the top one first. Oh no, I'll do the next one. Right, now imagine if I took a yellow ball from red, from A, and a red ball from B. What does that mean? It's still all out of 8. Okay. But we've added 1 more yellow, so that's 1 yellow and 7 red. For the next one, it's the same again. Okay, 1 yellow from B, another red from A. For this one, how many yellow? There's going to be 0 yellow, and then if we get red from bags A and B, we're going to get 8. I hope I explained that okay. I was trying to figure out in my head at the same time. So, tree diagram completed. It says show that the probability that Mike records a yellow ball exactly twice. So what is the only way to get it twice? Okay. The only way to get it twice is if we did red, yellow, yellow. Okay? Or yellow, yellow, red, or yellow, red, yellow. Okay, so we have the three options there. This is the only way to get two yellows, and that's what he said. Records a yellow ball exactly twice. So what is the probability of this? So for the first one, we could have red, yellow, yellow. We could have yellow, red, yellow. And then yellow, yellow, red. So we're going to have 4 over 6 times 1 over 5 times 1 over 8. Which is going to give us 6 times 5 is 30 times 8, 240. And that's 4 over 240. Then yellow, 2 over 6. Times red, 4 over 5. Times yellow, 1 over 8. Again, it's out of 240. And 4 times 2 times 1 is 8. Then the next one, we're going to have yellow, 2 over 6, times 1 over 5, times 6 over 8. So again, over 240, what are we going to have? 2 times 6 is 12. So 12 plus 4, 24 over 240 is in fact 1 over 10. Okay? Now it wants us to show it's 1 over 10. Done. Perfect. So guys, you know that you've done it right. Given that he records exactly 2 yellow balls. So this is given that. So whatever we have to figure out now is going to be over 1 over 10. Because it's given that he records 2 yellow balls. And given that means we can only go from our paths that we've done already. Find the probability that the ball drawn from bag A is red. Okay, what's the probability we draw from bag A? Red. Yellow, yellow is this one. So given that it's drawn from bag A, we're going to do 4 over 240 divided by 1 over 10. That is going to be what our probability is. Okay, which is 1 over 6. Okay, perfect. So nice and easy, 2 marks. So that was C, wasn't it? Okay, next part. So Mike plays this game a large number of times, each time starting with the bags containing balls as described above. The random variable x represents the number of yellow balls recorded in a single game. Find the probability of the distribution of x. Okay, so first of all, if we need to know the probability of x, and it said x represents the number of yellow balls, okay? So we can either get 0 yellow balls, exactly 1, exactly 2, or all 3, okay? So what do we know? We want to know the probability distribution of x. So what is the probability of having exactly 0 red balls? You know 0 yellow is going to be red, red, red. So we're going to get 4 over 6 times 4 over 5 times, let's say 8 over 8. Okay, so what is that going to give us? Pretty much it's just going to give us 8 over 50. Okay, 8 over 15. Now again, you might have different ones as long as... So what's the probability of getting 1? Now the probability of having exactly 1 yellow, again, so we could do red, red, yellow, red, yellow, red, yellow, red, red. Okay, so red, red, yellow, 4 over 6 times 4 over 5. Oh, we can't even do red, red, yellow, because then this is 0 out of 8. Okay, so there's no such thing as red, red, yellow. Okay, so that's something that we've figured out. Brilliant. Then red, yellow, red. Can we do that? We can. 4 out of 6 times 1 out of 5 times red, yellow, and then 7 over 8. Now we're going to add that to yellow, red, red, 7 over 8. Okay, so I'm going to add those both together, and that's going to give me simplified as 7 over 20. Perfect. Now, how about getting 2? We already did that. That was 1 out of 10. Okay, and then getting 3 yellows. Now, if I want 3 yellows, I'm going to get 2 over 6 times 1 over 5 times 2 over 8. 30, 80, 4 over 240, which is in fact 1 over 60. Okay, brilliant. So there we go. We found the probability distribution. It's D. Now, part E says find EX. Okay, so what is our E of X? Okay, and how do we figure that out? So we know we are going to do 0 times 8 over 15 plus 1 times 7 over 42, 7 over 20, plus 2 times 1 over 10, plus 3 times 1 over 60, which is going to give me 72 over 120, which is also 0.6, so either or. So there we have it. This question is complete. Okay, so question 5. The discrete random variable y has the following probability distribution, where Q, R, and U are probabilities. Write down the expected value of y. Now, by looking at the graph, I can already see what it is. However, the expected value of y is minus 9 times q. Remember, we're doing this times this, plus this times this, plus this times this, etc. So, plus minus 5 times r, plus 0 times u, plus 5 times r, plus 9 times q. Now, what do we notice? These are going to cancel, these are going to cancel. 0 multiplied by u is in fact 0. So 1 mark for that. Okay. Then it says the commutative distribution function of y is f of y. Given that f of 0 equals 19 over 30, show that the value of u is 4 over 15. Okay. So given that f of 0 equals 19 over 30, so what is our commutative distribution? Okay, f of 0, well, we know that this is q, this is going to be q plus r, this is going to be q plus r plus u. So that means that q plus r plus u equals 19 over 30. Now, if this equals 19 over 30, we know that they have to add to 1 when we're looking at the commutative distribution. So we're saying that our q plus r must equal 11 over 30. Okay, so if q plus r is 11 over 30, what do we know? 7 over 30? We know that this is 11 over 30, so that must mean u equals 8 over 30, or 4 over 15. Either or. Okay, so you can simplify it. Nice and simple. And then we've showed it. Okay. Then it says, given also that the variance of y. So how do we know what the variance of y is? Now, we know the variance of y is in fact... Oh, I've put the sum there. RE of y squared, which is, so y squared multiplied by q. So minus 9 squared multiplied by q, I'm going to get 81q. Plus 25r, plus 0u, plus 25r, plus 81q. Okay, so that's going to give me 162q plus 50r. Okay, now we're saying that this equals 37. Now we already know that q plus r equals 11 over 30. Okay, so now we have essentially simultaneous equations. We can do any which way. So I'm going to do q equals 11 over 30 minus r. I'm going to substitute that in where q is 11 over 30 minus r plus 50r equals 37. Okay. We can expand, rearrange, etc. So, okay, so we're going to get 1782 over 30 minus 162r plus 50r equals 37. Okay. So then I'm going to get minus 112r equals 37 plus 37 minus negative. So 37 minus oh my god, 37 minus 59. Okay, then divide by 1 minus 1, 112. So this is going to give me r as 1 over 5. Okay, so I can substitute that back into here. So technically 11 over 30, 1 over 5 is 6 over 30. So I actually get 5 over 30, which is 1 over 6. So q is 1 over 6. Brilliant. Okay, nice and easy. Sorry, I had a bit of issue with the calculator. Double check that you can get that all done. Now, it says the coordinates of point P are 12y. The random variable d represents the length OP. Find the probability distribution of d. Okay. So, what do we know? We know we have d equals OP. Okay, so if we think about our D, right, what do we have for D? Well, we have our Y is 0, 5, or negative 5. Now, when we're talking about lengths, these negatives and positives aren't really going to matter so much, okay? So the random variable d represents the length of OP. Now, when I'm thinking of my length OP, what am I thinking of? I'm thinking from my origin to my point P. Now, my point Y, so if you think about a length, this is O to P. And this is 12 and any one of my Y's. So my Y, for example, could be, we have minus 9, didn't we? Or we had minus 5, or we had 0. Okay. So if you think, how am I going to find the length of this line? Well, we know we can use Pythagoras. A squared, B squared equals C squared. And because we're starting from the origin, actually the lengths of the line are the coordinates. Now when we square a negative, it doesn't matter, so we're only actually going to have 3 values of our line, because when we square a negative we're going to get the positive, and when we square a positive we're going to get the same positive. So we could either have, so as we said, we could either have 12 squared plus 0 squared square rooted. This is going to give me my D, okay? Or we could have our 12 squared plus our 5 squared. Now remember, this could be the plus or minus 5. Or we could have our 12 squared plus our 9 squared. Okay, so what are we going to get? Now we know this is just going to give us 12. Pythagorean triple. Here we have, so this is going to be 13. And then 12 squared plus 81. I'm sure that's a Pythagorean triple as well. This is going to give me 15. Because it gives me 225. Perfect. So our values for D are 12, 13, and 15. Okay. Now, let's have a look at the probability distribution. So the probability of D equaling this. So what is the probability of D equaling 12? This is only when y is 0. For 13, this is when we had plus or minus 5. And then for 15, this is when we had plus or minus 9. Right, well, the probability of D being 12, the length being 12, is just U. Okay, because that was when y is 0, which is in fact 4 over 15. Okay, the probability of plus or minus 5 is R plus R. What was our R? 1 over 5, so this is 2 over 5. And then the probability of us getting a length of 15 is when our y was 9, which is Q, and Q, which is 2 over 6, which is the same as a third. Okay, nice and easy. I think that was a lovely 6 marks, actually. Brilliant.